Good afternoon, everyone. In the previous webcast, I did the Monte Carlo simulation. Now we would look into geometric Brownian motion. What is geometric Brownian motion? First of all, someone named Robert Brown in 1800s, he saw this pollen moving on water in a very random manner, and it was named after Brown. It was a random movement, and the equation for this was found later by Albert Einstein. And this equation cannot be used for stock market because the stock market or any markets, they are not 100% random. There's a random part and there's a deterministic part. So the separating out those two was the biggest problem. Now I want to show a video here. Okay, you could see now this is what Robert Brown saw. These dust particles or some small particles, they were moving very randomly, and if you could see this red line moving around extremely, this is total random process. Stock market or oil prices are not a total random process. I mean, if the production, we know that if there's give an example, if a new law comes that no fracking, then we know the production going to go down because they cannot frack do any more fracking, or there's a war in the Middle East or some problem. So there is a deterministic part for stock market or oil market or anything. But so due to that reason, we cannot use the total random Brownian motion equations. And a person named Wiener, very famous mathematician, he came up with a equation that has some type of a deterministic part and a random part. And this is the equation. It's the log natural STOS 0, and the delta t, A times delta t is the deterministic part, and B times WT is the Wiener process, which we will talk about it. So the ST is the oil price in this case, S0 is the previous price, the month before, and A is the coefficient for the deterministic portion. Now, how to find the coefficient for the deterministic portion? You have to go back to historical data and then simulate and then come up with a value. And B is the coefficient for the Wiener process. And what is the Wiener process? Wiener process is a function, basically depending upon a random, normally distributed number that is randomly occurring. And that function could be some complicated function, ax squared plus bx to the power 5 plus log natural to the power of something, any complicated function. I was told that some of these functions are guarded like top secrets by companies when they, let's say, for instance, they do a simulation for past 10 years and they come up with these functions and they guard those as a top secret because they spend a lot of money with computers and all these people and top MIT people working on this, and they come up with these numbers and then they're guarded top secret stuff because it's very difficult to get these numbers. And even so, even if you spend all that time, and still the future is future, future can happen anything. So but anyway, that's what the Wall Street people do. So this is the equation that I'm going to use. Now what are the steps in the Brownian motion? Step 1, look at the historical oil prices. Find the coefficient for the deterministic part, that will be the A. And then you have to find a function for that, and also you have to find the Wiener process. So find the coefficient for the deterministic part, then assume a function for the Wiener process, and then find the coefficient for the Wiener process. This all has to be done using past data. And then you simulate many times, and then find the component analysis, and then you would know which area that is beneficial to you and which phase space, which area in the phase space is beneficial to them. So this is the Excel spreadsheet that I did for the geometric Brownian motion. Here, let me see. Okay, this is how. So this is my normally distributed number, and this is the equation here, ST over S0, and this is the normally distributed number that I used, and time is 12 months, and then the oil price would be here. It would be, oil price has two parts. One is the deterministic part and the random part, and then here you have the function, and I did assumptions here. What are my assumptions? If you could see, I made an assumption A, the deterministic part, the coefficient is 0.002. How did I get it? I just look at some oil prices, and I didn't do any simulation with the historical data, just guessed it. And for the Wiener process, I guessed 0.1. Again, just a guess. So this is, someone could say, how do you get these coefficients? And all what I'm going to say is I just guessed it. In real life, you have to look at the historical data for past 10 years, 5 years, and then you do a simulation, and then you do a curve fitting, and then you could get those functions. And so using this, I could calculate the SL payment to the oil manufacturer as Deutsche Bank cost, how much Deutsche Bank has to pay, and then strike, all that good stuff. And then, like before, I have a on the left hand side is the oil price, and the right hand side is the SL cost with and without hedging deal. So if I press F9, let's see, F9, everything changes. Again, like before, orange line is SL cost without the hedging deal. So we are paying more without the hedging deal in this simulation. Press F9 again. Now, if the oil prices stays up like that, then it's good. And now here it's dipping down, and here again it's dipping down. This area is what we pay. When the orange line is lower, that's what we pay. That's another simulation. And then here we make money. So here it looks to me like, sometimes whenever they lose by a very well known amount. That would be $10 per barrel. But when we lose, there is no limit. It just goes down. So this is the analysis, risk analysis using geometric Brownian motion. Again, as I said, I guessed some of these parameters. You cannot guess them in a real life. You have to do a historical data analysis and then simulate and do a curve fitting and get those data. Thanks a lot for listening.